Good afternoon, everyone. I hope you're well. If you've already attended us today, I hope you've enjoyed some of the webinars that have been going on this morning. So we have a few more coming up today and also a question time later on. Today's session, this one will be about passive house insulation, performance, detailing and installation techniques. And this will be presented by Jasper Mead from PYC Warmsau. Before we begin today, I'd just like to point out a few functions on Zoom that you can use to interact with us today. So if you wanted to put forward a question, then please use the Q&A function, which is at the bottom of your screen in the middle. And at the end of the presentation, there'll be a short amount of time for Jasper to answer some questions for you. But please remember, we do have a question time at 3 o'clock today. So if any questions are missed, then please come to that session and hopefully they'll get answered later on for you. I've also like to mention that these sessions will be recorded as well. So we'll send out a link to you later on today. So if you wanted to review or have a look at the content again, you're welcome to do that. We will be monitoring the questions and the chat function as well, but please make sure you put your questions in the Q&A so we can monitor those. And I hope you enjoy the session today. So Jasper, if you're there, we can pass you over and get started.
Hello.
There we go. If you'd like to put your camera on, there we go, Jasper. So if you'd like to share your screen, and there you go. All right, thank you very much.
Hello, everybody. I hope you can see my screen. I'm going to be presenting to you on warm cell insulation and timber frame techniques and how that all works. I'll firstly introduce you to our company and then move on to the timber frame and how that's developed over the years, and then discuss warm cell insulation and further inspections and quality control on that. So we started our business 27 years ago, and we were, myself and my brother and our team, and we were mainly involved in renovations of old timber frame buildings, barn conversions, predominantly timber, and we looked out for products to use within that system, ideally sustainable, high performance products, and warm cell became that product for which would do all our insulation work. So following on from working with old buildings, we soon started to do extensions, and those became built out of softwood. And moving on from there, we then started doing new build timber frame, finding it much easier, as you can imagine, than working on old buildings. And so we could all pre-design everything and get it right from the start and work to the maximum energy performance standards we wanted to. So just some of these pictures are showing you some of the projects that we've worked on over the years. Our company set up, we have a piecewise installation which deliver the warm cell, and we distribute through a network of installers all over the country, some being timber framers who use the installation for their own systems, and some are installers who will work on self-build projects and other projects. We also have a construction division where we do timber framing, mostly working local to us in mid Wales, and we do an I-beam system there. The system section, it covers products that we use within our own builds, but also we deliver to other projects through self-builders and builders around the country. So we do the ProClima air tightness system. We get involved with MVHR systems, although that tends to be passed directly on to the manufacturers or installers. And we also do air tightness testing, which really helps understand our own builds and performances that we gain in that. And we work very closely with Green Building Store on timber windows, triple glaze, high performance windows. Xfloc is a machinery manufacturing company for the delivery of blown insulation. So we work with that company for selling machines to our installers. About 5 years ago, we built ourselves a factory where we moved our offices to, and we used timber frame system on that, albeit built onto a portal steel frame. And the first building we built there was our Passivhaus offices adjacent to that building, and that's where we are based at the moment. I'm working from home, but like most of us, but we do have our building team back there and a couple in the office now. Shot inside the office. We work very closely with wood providers, so we focus on showing our timber systems. So timber frame is the main usage for warm cell insulation, although it goes into all kinds of roof structures. And one of the things I'd like to demonstrate with this is that timber frame is often seen as a new product in the market, but clearly timber frame has been around for years. So when somebody says to us, I prefer to work with a traditional system, we certainly say that timber frame is very much traditional. Timber frame, when it started, was with 90mm walls, CLS, and then because the insulation standards changed, we then moved on to using 140mm CLS. But as you can see from this sort of system here, this was just a straightforward 140 frame. You get a lot of cold bridging through the pairing of studs for either for supporting lintels or column supports, etc., around the building. By default, when you calculate a U value, you have to work out what the percentage of timber is within the structure, the timber fraction, and by default you're allowed to use 15%. But the reality of a frame such as this, it can be as much as 25%. So that would be 25% of your wall area with no insulation in at all. So to avoid that, we looked at other systems, which was fitting small sections of timber across the face of rafters or studs to cut down the cold bridging to these sort of points here. But it became a bit of a fiddle, and although it works very well, it's not very practical for building or for insulating. So there are other forms of structures which you can use, and posi joists, strangely designed for floors but not used in this situation, but they can give you an extra thickness, but there is a risk, and particularly with Passivhaus, where it's very important, of cold bridging through the steel structure. Twin frame is a very successful way of building timber frame super insulated houses, passive houses, and we've worked with numerous and still do with twin frame. Larson truss is another form of this, where you have either an external or internal structural stud, and then a very lightweight stud work which builds out the thickness. and that's formed together with fins of OSB, which gives you that overall thickness of insulation and reduced cold bridging. So with a twin frame, you get the reduced cold bridging through the fully filled voids between the two frames, likewise with the Larsen truss. I-beam is another method. This is what we use, but I-beam is another form of construction where you've got the flange being the structural element glued through with the web between, and as you can see from that, you've got very much reduced cold bridging through that web structure. So that lends itself for passive house. This would be a typical formation of an I-beam frame using cellulose fiber. Similar to twin frame, we often would put in a 50 by 50 service zone, which is a very good idea to do on any passive house build using timber frame. It means that you're not going to penetrate the air tightness and vapor control layer with your services. So all your services can run through on the service zone. If you should consider that you need extra insulation to what's formed within the structure, you can also insulate that surface zone. So fabric first is certainly the approach to take in your timber framing, and insulating as best as you can, ensuring that the whole building is as airtight, as well insulated as possible, and running these through PHPP will mean that you can actually benchmark that that has been done. And then as a last look, we would say bolt-ons such as renewables or fancy heating systems would be the way to look. So looking at all the key points with passive house, you've got cold bridging, insulation, air tightness, wind tightness. The wind tightness can't really be measured, but it's a vital part to the success of a building. And then windows and solar gain, and of course ventilation. So these can be dealt with, cold bridging can be dealt with an I-beam system or twin frame system, fully filled with cellulose fiber insulation. The warm insulation is how we work with that. Air tightness, you can use membranes, tapes or boards and to get your air tightness. Wind tight, vapor open membranes on the outside, which will also act as your weather check. And then triple glazed windows, timber frame, like what we get from Green Building Store. And of course, ventilation systems dealt with your MVHR. There's a little video here, which I won't actually run through because I'm sure most of you are familiar with Passive House, but please take note of the title of this. You can find it on YouTube, Passive House Explained in 90 Seconds. Very useful little video clip to look at if you're unfamiliar with Passive House, and certainly to demonstrate to other people about how well it works. So part of the design analysis for a passive house and working with timber frame is that you need to look at all the different performances of your structure. So for a very straightforward structure, we would run through U-value calculations using JPA software. But if there's anything a bit more complex, such as a warm roof, maybe with a single ply membrane, perhaps without ventilation above the insulation, we would then run it through the WUFI software, which will give you a much more accurate analysis of whether or not there's any condensation risk, but of course it will calculate your U values for you as well. A lot of people would say, let's build to passive house principles, and not necessarily certificate or check that those principles are being met. We would advocate that the PHPP, the Passive House Planning Package, is a very good tool, very efficient way of analyzing the building, working out that your insulation value is going to give you the performance you need, working out whether you've got only overheating risks, ventilation strategy. So it's an overarching design package which will ensure that your building performs. And even though you might not certify, I think it is very valuable to run your program, your building through the PHPP to ensure that you are going to get what you're designing. Of course, system details, whichever system you are going to use to build with your timber frame is vital to make sure that every component complies in respect to cold bridging and insulation values. So for instance, a timber frame manufacturer such as ourselves could take on board a project from planning permission, and then run through in collaboration with your architect to get building control drawings, design the building, the timber frame through from that point. It's useful, if possible, to get a timber framer on board at an early stage, particularly so that the structure of that building can be understood, so that the timber framer can inform you about costly supporting beams, etc., which you wouldn't want to include if you didn't have to. And again, of course, PHPP engineers would run through their process and then enable the timber framer to produce the manufacturing drawings. And this is a typical method of manufacturing on tables. And here you see a closed panel insulated, airtight, vapor control layer on the outside. This is using a certified board here, and there's your external wind tight layer. Then an erection on site, panelized, can then speed up that build dramatically. So coming on to the insulation, your architect, your designer will look at a U value that is stated on data sheets, etc., from an insulation manufacturer, and will work out what to expect in the design of the building. But if that doesn't happen, doesn't get built as planned, if you've got gaps on the inside, gaps on the outside, you're clearly going to get airflow through the insulation, and that's going to cause cooling. That cooling will reduce the value of that insulation. If you've got gaps within the insulation, you're going to get convection looping. That convection looping will cause cooling. So you've got cool air flowing down the gap, cross, warm air up, and then so on. So you lose dramatically, can lose heat. If you have a blown insulation, such as warm cell cellulose fiber insulation, injected into that panel, fully filling the void side to side, top to bottom, you will get what you're designing, and resultingly no performance gap. These are very much real photographs of situations where not much attention has been paid to the fitting. And these, as I was saying, real photographs from sites. This particular one is always quite amusing, where the builder was asked by the architect why he fitted the insulation in that way, and the builder said, well, that was how you drew the insulation. So you can't fail him for that one. If you do air tightness testing and thermal imaging on your structure, you will produce results like this. And so this clearly shows where cold bridging is occurring along perimeters, along joints. This could be either through solid timber structure or gaps in the insulation. So cellulose fiber insulation, made from recycled newspaper and treated with boron salts, Epsom salts, to give it protection against molds. Any fungal development cannot happen within that. And it also gives it fire resistance and keeps out insects and any kind of vermin. It's blown into the structure. I'll explain in a little bit about how that happens. It's very dense insulation, so it's blown under high density, typically on a 300 mil wall, which is the sort of minimum standards really that you'd be looking at on a house for passive house standards. It would be going at about 65 kilos per cubic meter. So that density really helps give you stable temperatures and prevent overheating in summer months. So you get very good decrement delay there, for instance. Because we've been involved in air tightness testing, we've had a lot of opportunities where we've been able to run air tightness tests prior to the fitting of the insulation and then post fitting of the insulation. And that enabled us to see that by blowing the insulation into the panels, the cellulose fiber into the panels, it has given pretty consistently 30% improvement in air tightness. So the manufacturing process, recycled newspaper, it's quite a sophisticated process, even though it's a very simple product. It has to be manufactured to the high quality standards that buildings need. The papers are collected, milled, ground up to a certain fiber size, and then mixed in the factory with boron salts and Epsom salts. The process of that is not just a dry mix of salts and paper. Both elements are heated to 80 degrees, and that means that the salts become very tacky and they bond extremely well to the paper. So you get that full homogeneous mix, which gives it the protection required. So the insulation is once fiberized, once completely manufactured, is then baled and delivered, and we have depots all over the country for enabling delivery out to projects wherever, down in Penzance or up in the Highlands of Scotland. The theoretical performance of insulation is measured with by giving you a thermal conductivity. The thermal conductivity of cellulose fiber, the warm cell, is 0.038. That's in line with the majority of other blown fiber insulations, natural insulations, and the fact of blowing it ensures that you actually do get what you're designing with that thermal conductivity. So the thermal conductivity combined with the thickness would enable you to calculate the U value. Warm cell is very hygroscopic, and that means it can absorb and release moisture very readily, which is a big bonus for timber frames. So if you've got any risk of any kind of moisture getting in within the structure, it can breathe very readily through the insulation, so you don't run risk of any condensation points on timber or boards and membranes. You get that flow of vapor very readily. And the specific heat capacity is a measurement of the ability for the insulation to, you won't be able to see this very clearly, but essentially, because it's such a dense insulation, it can absorb and release moisture, it can absorb heat and retain it for quite a long time before it would then release it. So for instance, on a warm roof where you had sun beating down on the roof, so it's like an attic bedroom or a sloping ceiling insulation situation. So the sun beating down on the outside with a lightweight insulation, it would take about 3 or 4 hours for the insulation to heat up, and then that heat would start permeating into the building, and so you would run risk of getting quite warm, hot in that bedroom, for instance. With a heavyweight insulation, U value comparison using something like cellulose fiber, that it would take up to 11 hours before that heat would start permeating into the building. That would enable you to keep cool. It also helps in the winter months to give you very good stability of temperatures, so you have a very low risk of fluctuations of temperature, which means much more thermal comfort. On environmental point of view, all products, all insulation products as well, have to have what's known as a global warming potential. So this is a calculation that's carried out on what is the embodied energy in the manufacturing process of the insulation. And the manufacturing process is very low carbon usage for manufacturing warm cells, so the embodied energy is very low, and you're also going to be locking carbon into the building. The paper, of course, made from timber, so your timber frame and the insulation, carbon content, so you're gaining very good points on carbon sequestration. The GWP expressed here has been tested out to be -1.5, which is the lowest available on any insulation product. Fire, which isn't a great subject to be talking about in any kind of buildings, but just it's a question that is always raised. So this clearly demonstrates how well the warm cell can perform against fire. So what's happening here is we've got a penny on a layer of warm cell on my hand, and with an oxyacetylene blowtorch it's blowing heat, flame onto that to very high temperatures, up to 1,000 degrees this would be, which is clearly melting that penny into a molten ball and charring the insulation around. So even though cellulose fibre is made from wood, it is not burning. So what is happening is that by water crystallization, the boron salts, by water crystallization, create moisture within the surface of the insulation, which causes charring, and that charring helps prevent further burning, slows it down dramatically. So here you've got taken the heat away and the flame goes out. So although it's a cellulose fibre and you can't get, the classification is C, you can see here that there is very good performance in slowing down that passage of flame. It also demonstrates very well that heat doesn't pass through it. So the installation processes, so warm cell can be blown into external walls, warm roofs, that's sloping ceilings, and flat lofts. So blowing through a flat loft, you can fill any kind of void to any depth to ensure that you get to the U-value standard you want to. We also use it for acoustic reasons, for intermediate floors, for party walls, partition walls, because it's so dense, you get very good sound absorption between between the walls. One place where you wouldn't fit it would be on a brick and block cavity wall situation. There's just too much risk of potential leakage through the external wall, unknown factors of what the vapor control there is, etc. So you have to be extremely careful in cavity wall structures what insulation you do use, and we stand back from that and wouldn't actually suggest using it in a cavity wall. Part of our service would be technical support that we provide for your insulation for your projects, is to work out what U-values you would get. So if we get a breakdown through your wall structure or your roof structure, so identifying every single component, we can then work out what the U-value would be and also advise on whether or not you need to increase that vapor control, or perhaps you don't need that board. So we can help you design that structure. The installation process, it happens via fitting, but by blowing through with these machines. So we have the mini fant here through to the EM440. Mini fant would be for installers on site, although they can be used in factories as well. The EM440 is a factory machine. Injection is the main process for fitting cellulose fibre, and usually in closed panels. And so it can be injected via nozzles or through with a hose feeding down slopes, or using needles, which is probably the most common process. And then that's showing you the loft install. So yes, you can see it's very quick and straightforward process of just blowing to the depth required. That's actually showing a decking area for a loft. These are just little diagrams to show how the injection process happens through a sloping ceiling there, a flat ceiling, and then different wall structures. It's blown under high pressure, so it enables it to reach every single corner. This just to show how factory application machine, so the grey box on the back of the blowing machine will take a full pallet of insulation. So the full pallet goes into the box. There's a ram that pushes that pallet up. It gets raked off the top, dropped into the machine, and then fiberized and blown under pressure down the line to production table and injected through this plate into the panel. This is all remotely run through computer. Just to recap on the different installation methods. So lofts at the top there, sloping ceilings, walls, injection into walls. This is how we used to do it a lot in past when we were blown up to 150 mil. So mixed with water, you would be able to spray to open stud work. It's now used perhaps for acoustic insulation on ceilings and places like that. And then into panels in a factory install, perhaps you've got panels stacked up and then injected through lances from the ends. And that bottom diagram just shows you production line manufacturing. Quality control is key to passive house builds, to any builds, to be fair. So there's various ways you can do this. So density, ensuring that there is a complete fill of the insulation is probably one of the biggest concerns that somebody might have. To address this, we've developed a core cutting system which will take core samples of the insulation and work out exactly what densities are within that structure. That means that you can benchmark this against the prescribed densities that you would need. So for instance, a 90 mil wall will need 45 kilos per cubic meter, and a 300 mil wall would be about around 60 kilos, up to 65 depending on the manufacturing process. And so you can work that out and measure it and record it from there. Using the timber framing software, we can demonstrate exactly what timber content's gone into the building. And so with that, and there's a ribbon developed for PHPP by Tim Martell, which will give you analysis of your the carbon content, the embodied carbon in your building through PHPP. Of course, weighing the panels before and after manufacturing will also give you, before and after the installation will also give you a measurement of what insulation's gone in there. But this happens in the main so that you can work out for transportation and craneage. And then of course the PHPP and the insulation tests. I'm just going to run through a few different projects where warm cell's been used. This was the largest timber frame building at one stage, if not still, in Norwich, the UEA, and it's an amazing building with fantastic feel internally and very comfortable building. So this was built to passive house standards using sustainable materials as best as possible. Passive house schools have changed a lot of the ways that councils can run and manage their schools on a much more effective budget. For instance, schools of similar size, historic schools built to building regs in comparison to passive house schools have had such as much 90% improvement on running costs, which over the years saves considerable money. But let alone the financial costs, the buildings are so much more comfortable to be in. So the carbon dioxide levels are dramatically reduced, and so attention span of kids is far greater, and fluctuations of temperatures don't happen nearly so much. So it overall provides a much more comfortable learning environment. Just showing you some other ones which demonstrate different types of buildings where you can use cellulose fibre insulation. Having worked on a lot of the first passive house buildings in the UK, this was the first commercial building, the first passive house offices in the UK back in 2008. This has given us a lot of experience and understanding of how all this comes together. It's the first passive house build, quite a well-known photograph, which you might have even seen already today in other presentations. And just to show that timber frame can carry quite high weights. So for instance, here we've got a turf roof on a timber frame building. This was a twin wall because of the weights. Both walls were structural on the twin wall. All sorts of different shapes can be used and different vernaculars. This is a site of houses, 30 odd houses in Stroud. Very, very timber friendly buildings. And then conventional buildings where you would never really imagine that they were timber frame when you looked at them. So these got masonry externally, but these are all timber frame buildings. We did a lot of sound testing on these buildings in the party walls. So to get a sound test as a robust detail, you have to carry out 20 tests, I believe, over 5 different sites, 5 or more different sites, and this was part of that process. The acoustic performance between walls, building regs would be requiring 48 dB sound reduction. We were consistently getting 54 dB sound reduction. We've probably worked on the thousands of houses down in the South Wales area, Manchester and Liverpool, with warm cell insulation. The timber frame doesn't have to look like timber frame either. This is a building in the Cotswolds, timber frame. And believe it or not, this is a timber frame building as well, all insulated with cellulose fibre. So this was once the tallest timber frame building in Britain. Even the chimneys are actually timber frame with a brick cladding on them, and obviously a stone facade to match in with the existing buildings. And as it was listed, it had to look like it originally did. So we're moving on to some recent projects. This is a passive house that we built in Surrey, and then there's been some quite large schemes in this one's in Norwich, 100 odd houses. Michael Richards, the architects on this project, all timber frame and insulated with cellulose fibre. What's great about this one is built to Passivhaus standard, certified, and it actually won the Sterling Prize for Architecture last year. You can see this featured in the Passivhaus Plus magazine. If anyone's interested, I can send you links. They're all available online at the moment because of supporting during the problems we've got. These are some schemes. This is a scheme in Shropshire, Passivhaus scheme. Quite like this photo because the renders, the architect's renders and the actual photographs look very similar, and but they are very real. I'm just going to run through very quickly some about modular housing where we've used cellulose fibre, just out of interest for you really. There's different schemes where we've built offsite with CLT, finished grade CLT, which is then formed into smaller buildings assembled on site, small sections assembled on site to form buildings. And this really frees up capabilities on tricky sites where you can't afford to spend too much time perhaps for weather conditions or site access. And then this particular project was a scheme we worked on a couple of years ago, and it was 60 units. And where this was particularly interesting was that the box of student accommodation, 4 meters by 3 meters, stacked on top of each other with no actual supports on the outsides. I'm just going to run through this little video for your interest. So that's me. I hope you found that interesting. I hope it's useful.
Okay, thank you, Jasper. We do have a couple of questions for you, so give me a second. Let's have a look at some that we've got here. So the first one that we're going to ask you is from Nicholas. And the question is, does warm cell ever settle over time? Does it leave a gap, or say at the top of the wall panel, will it leave a gap over time?
If installed to incorrect densities, then that is a risk, which is why, as I showed the density check-in that you do, that ensures that you install to the correct densities. So we've had the opportunity to go back to projects which we've built, and because of building an extension or knocking through doorways, etc., on the old buildings, and where it's been installed to correct densities, we've not seen any movement at all. So it's been tried and tested. So one thing I didn't actually say is warm cell is still quite a niche product in the UK, cellulose fibre blown insulation, yet, and so you might say that perhaps, for instance, there might be 1,500 tonnes used in the UK every year. The rest of Europe use 250,000 tonnes, and it's used, cellulose fibre is used on something like 40% of new timber frame builds in America, equating to sort of 1.5 million tonnes, and phenomenal use. So it's tried and tested outside of the UK as well. So yes, the answer is yes. If it is installed badly, there is a risk of settlement, but installed using the correct machinery, tools, and doing density checks, no, it won't.
Okay, thank you. Thank you for that one. One more here. So would you ever consider changing to wood fibre blown-in insulation in your buildings? With people reading and writing using screens rather than paper these days, is there still plenty of newspaper around to be recycled for the foreseeable future?
There definitely is. So as I said, the figures are extremely low, what is used in the UK. And in London, Evening Standard, the Metro, they produce 90 odd thousand tonnes per year of paper, and the majority of that is currently burnt. So there is a vast resource still available.
Okay, brilliant. So one more question. Does factory injection in panelised systems rather than site injection in a stick build system achieve better insulation and air tightness standards?
No, I would. There are different methods of installing, but if you fit it on site or fit it in the factory, you will get the same performance. So there's absolutely no reason not to do it on site. It works very well as well.
Okay, brilliant. Okay, thank you very much for that, Jasper.
Pleasure.
It was great, so brilliant. I've got, a few comments on the chat as well saying very interesting, thank you, so that's great.
Good.
So if you do have any more questions, then please come to our webinar at 3 o'clock. There'll be a question time to talk to any of the panelists and get your questions answered if you haven't already done so. And next at 2 o'clock, we will have Ben Adam-Smith with his Passivhaus case study. So thank you very much, everyone, and we will see you at 2 o'clock. Thank you. Bye-bye.
Thank you. Goodbye.